Hey, good morning, everybody, and we're gonna get going here in a few minutes or so. Ask you to hang tight for a little bit. Get to see how many more people can kind of join in. I'd say maybe a couple minutes after 11, we'll get going with the training on TXVs and SpacePak. If you're just popping in, everyone, we're gonna wait a few more minutes here and let some people keep trickling in. Probably start the webinar here just after 11. Morning, everyone. We're gonna wait 2-3 more minutes here, let some people trickle in. Looks like we've got a pretty good crowd coming in right now, so give it a couple more minutes and then we'll get going. Thanks. All right, everyone. Well, it's 11:03 now. If people keep rolling in, they'll catch up on it. So, good morning. Welcome to TXV training for SpacePak, presented by our friends over at Sporlan. First, wanted to thank everyone for taking time out of their busy schedules to come out today and join on this webinar. We know being a Monday, everyone's got a lot on their plate, so really appreciate you guys logging in and learning on TXVs with us. Also good to see a lot of familiar names in the attendee list here. So that's great. See you guys out and helping to continue to support Mestech and all the brands that Mestech offers, including SpacePak, obviously, during all the supply chain issues, vendor shortages, and et cetera, that we've run into this year. So it's really great you guys keep supporting us. Couple housekeeping items on webinars for people who aren't too familiar with them. Right now, you guys are all muted. That's on purpose. So if you have questions, on the right-hand side, you should see a questions box and a chat box. You can enter questions in there as needed, in either or of those, really. Myself and a couple other moderators of this will be kind of monitoring them as they come along. We'll try our best to answer them during the presentation, but if we don't answer them during the presentation, we'll try to get to them at the end. We've left some time at the end here to go over any questions. The whole presentation should be about 45 minutes or so, so we'll give some time to answer questions toward the end. So who am I? Who's talking to you right now? My name is Dan Torres. I'm the product manager for SpacePak. My job is to work with our technical support team, sales team, manufacturing team, pretty much anybody that has to do with SpacePak team anyways, I have a hand in. specifically with vendors and also our manufacturers reps and customers and everybody else. I'd like to also introduce someone in the room today. Jim Bashford is our National Sales Manager, who a lot of you may be familiar with, especially our reps that are in the room right now. Jim's going to be a great resource for anybody in the future going forward with all things related to SpacePak. So I know Jim's out there right now. You know, why are we here today, right? We're here today to discuss TXVs. This is good for continuing education on TXV troubleshooting, learn more about them, installation tips, the functionality and construction of TXVs. Every SpacePak DX air handler that we manufacture has a TXV installed from the factory. It's important for us and for you guys to understand the purpose of these TXVs. So if something does go wrong, we can determine if the TXV is the root cause or if it's not. And eliminating the TXV as a potential failure should help steer technicians towards the proper root cause and hopefully save on, you know, callbacks and you know, any other thing else that could bother, you know, technicians out in the field. So really trying to minimize your guys' time in troubleshooting. Obviously, TXVs are a huge part of refrigerant-based HVAC systems in today's world. So we hope that this training may help you with other products as well, not just SpacePak. So I keep saying, I keep talking about SpacePak. So hopefully everyone here should be familiar with SpacePak, but if you're not, we are a manufacturer of a small duct, high velocity air handling system. We're owned by a company called Mestec. These units are manufactured down in North Carolina. Part of the SpacePak team is our engineering team, our sales and marketing team, our customer support team, pre-sales team, tech support, et cetera, that you guys can see there on the screen. Mestec, as the principal company, owns roughly 46, 47 different manufacturing companies throughout the United States, Canada, and China. And these are all manufacturers geared towards HVAC industry one way or another. So with all that being said, I'd like to introduce Dana George from the Sporlan Company. Dana has been working with Mestec as an OEM supplier for a long time now. I've known Dana for probably 10, 11 years working here at Mestec, and he's worked, as you can see, his resume here is up on the screen. He's got 13 years in the HVAC distribution channel. Dana is a wealth of knowledge, and we're lucky to have him here today spending time with us, explaining a little bit about TXVs. So after all that, I'm going to let Dana kind of run with it here, and I'll probably chime back in towards the end. So Dana, all yours, man.
Thank you, Dan. Can you hear me okay?
Yep, hear you just fine.
Great, thank you. So, yeah, like Dan said, I've been with the Sporlan Valve Company now for 16 years. I've got wholesale and OEM responsibilities, as well as calling on contractors. And a big part of my job is tech support. So I've seen a lot, you know, obviously with expansion valves over the years. I've seen the good, the bad, and the ugly. And I think a lot of times the expansion valve is a misunderstood component in the refrigeration system. So first of all, Sporlan is based in the United States. Sporlan is manufactured in Washington, Missouri. And then here's the factory telephone number, 636-239-1111. So we're setting up this training today. Here's the agenda that we determine how the expansion valve works, installation tips, and then service and troubleshooting tips. So this is all geared towards installation and service. You know, this is not a sales pitch. So let's start out with the basic refrigeration components. You know, you have the four basic refrigeration components. You have the compressor, you have the condenser, and then you have the evaporator, and then you have the expansion valve. So I think a lot of times the expansion valve actually ends up being misdiagnosed because of other issues going on in the refrigeration. Let's first take a look at the function of the expansion valve. So here you have a liquid line with subcooled high pressure liquid feeding the expansion valve, and it's the function of that expansion valve to create a high pressure drop across it so that you can basically drop the pressure of that 410A, thus lowering the boiling point of that 410A so you can absorb the heat going over that evaporator. And it's not really the function of the expansion valve to control temperature in the room. The only function of that expansion valve is to control superheat at the outlet of the evaporator. Now, does one affect the other? Does the superheat at the outlet of the evaporator affect the room temperature? I would say definitely it does. So if you look at the metering device in this situation, the thermal expansion valve, and another important part of the distribution of that low pressure saturated refrigerant into the evaporator is the distributor. So towards the tail end of this training, I'm going to be talking about the distributor a little bit. And then if you think you're having an issue with the distributor or the distribution of the refrigerant into the evaporator, what are a couple of the things that you can check to see if it may be a distribution issue? So taking a look at the expansion valve and how it operates, and I just first want to point out that this is an imbalanced port expansion valve. So this is an imbalanced port expansion valve. And then in a few more slides, I'm going to demonstrate a balanced port expansion valve and what the difference is between the two. And then just a side note, all 410A expansion valves need to be a balanced port expansion valve. So taking a look at the anatomy of the expansion valve, you have the inlet connection, you have the outlet connection, you have the main body of the expansion valve, you have the pin and the port, and then you have the spring, which acts as the closing pressure, and then that's adjustable. So that's how you would adjust the superheat on the expansion valve. And then you have the diaphragm and then the bulb of the on the element. And really, if you look at the magic and how the expansion valve works, the major opening pressure is the element. So where does the bulb get strapped to on the evaporator? It gets strapped on the outlet of the evaporator on that suction line. And then for this training, MESTEC uses our GA charge. So the GA charge is a gas cross charge. So there's a gas in the element and in this bulb. So as your evaporator load increases, your superheat is going to increase, or your suction line temperature increases. And as your suction line temperature increases, this bulb temperature increases and the bulb pressure inside increases. And when that bulb pressure increases, there's a diaphragm in here that deflects down, moves this pin away from the port of the expansion valve, and it allows more cold saturated refrigerant to enter into that evaporator to make it more efficient or to try to catch up with that heat load. Now, as you catch up with the heat load and as your superheat starts to drop, now your bulb temp or your suction line temperature gets colder, your bulb temperature gets colder, your bulb pressure decreases, and then this diaphragm flattens out, and then the spring pushes that pin against the port of that valve, and now it starts to throttle back the amount of refrigerant entering into that evaporator, so that so that we protect the compressor from any type of a liquid slug. So if you look at how this expansion valve operates, basically this pin is just operating, moving back and forth from the port of the valve based on that bulb temperature or your superheat. So when you look at what is superheat, as heat is applied to the saturated vapor, superheat is created. So if you look at the forces that act on the expansion valve. As I mentioned in the previous slide, the bulb pressure opens the expansion valve, and then there are two pressures that close it. One is the spring pressure, which again is adjustable with your superheat adjustment, and then the other pressure that helps close that valve is the evaporator pressure. And then on an external equalized valve, that equalizer line pressure helps close the expansion valve. So first, calculating superheat. You need to, know obviously what the refrigerant is in the system. You need to know what the pressure is. You need to look up on the PT card to see what the saturation temperature is or the boiling point of that refrigerant is for that pressure. And then measure the temperature at the outlet of the coil, and then the difference is your superheated value. So let's take an example of that. With 410A and typical air conditioning, on our gauges on the outlet of the evaporator, we're measuring 118 PSI. So you go to your Sporlan PT card, you look up, okay, what's the boiling point of 410A at 118 PSI? And the saturation temperature, the boiling point of 410A is 40 degrees. Now the actual temperature we're measuring on that suction line is 52. So we're 12 degrees warmer than that boiling point, and we're at a 12-degree superheat. Now I get asked, what do you recommend for superheat settings on a system? And kind of the first thing I say is, you want to check with what the manufacturer, what they recommend. But as a guideline, here's our recommendation. For an air conditioning or a heat pump application, we say anywhere from 8 to 12 degrees superheat is acceptable. And then typically if it's set for 10 degrees superheat, it's not going to be flatline at 10 degrees. You are going to get a little bit of hunting. It may go from 8 to 12 degrees of modulation on that superheat setting. So you want to make sure that you want to take that average value. And then the other thing is too, when you're starting up a new piece of equipment, you want to let it run, let it pull pull down as close as possible before you check the superheat setting, because if you're turning on that SpacePak air handler and it's a warm house, then your superheat is going to be high because it's removing the energy or the heat from that building. So let it run, let it pull down as close as it can, and then check the superheat and then make adjustments as necessary. So, we want to make sure that the expansion valve is set so it's not too low. So you want to protect the compressor from any type of a flood back, which can wash away the compressor oil. You want to make sure, you have you're at a superheated condition at the inlet of the compressor, so you're not going to slug the compressor, so you're not going to damage valve plates or crankshafts on the compressor. And then also you want to make sure that the superheat isn't too high. What happens when superheat is too high at the outlet of the evaporator? Your superheat is going to be too high coming back to the compressor, and then you're going to get high discharge temperatures at the compressor. So here are some methods to reduce discharge temperatures on your compressors. So one, check your expansion valve superheat. That creates a high compressor superheat and creates high discharge temperatures. One thing that needs to be done every spring is cleaning the condensers. Has a huge effect on how the equipment operates, especially after pollen season. You get a lot of the pine pollen that ends up getting plugging up the tube and fin condensers or the micro channel condensers. So it's important that you make sure that condenser is clean, so that you can reject all that heat that's being absorbed by the evaporator and the heat of compression from the compressor. make sure that your suction lines are insulated as well. Make sure that that armor flex isn't worn off over a period of time. And then lowering your compression ratio. That just means, making sure your evaporator pressure is as high as possible, that you can still pull that room down. And then making sure your head pressure is as low as possible. And that gets back to this guy here, cleaning the condenser. Make sure that condenser's clean. So, on a 95-degree day, you can make sure that you have subcooled liquid coming out of that condenser to feed your expansion valves properly. And then checking your expansion superheat. So here we're just demonstrating an internally equalized expansion valve versus an externally equalized expansion valve. Whenever you have a distributor on an evaporator, you should always have an externally equalized valve. So for the CBBI valves that are installed on the Mestec units, they have a distributor and they're all externally equalized. And I mentioned the external equalizer helps close the expansion valve, and that's the evaporator, and we want that evaporator pressure to be at the same location as the bulb temperature. So if you look at this scenario, we want this suction pressure is 55 psi, so that 55 psi comes up that equalizer line, and you can see where it acts right against that diaphragm pressure to help close that valve, in addition to that spring pressure. I have had situations where this equalized, that equalizer line was clogged or it was restricted. And when that happens, it simulates a bad expansion valve or a dead element. So you'd have low suction pressure, high superheat, and that would come from a restricted equalizer connection. And then the other thing I want to point out is, ideally we say we want to make sure that equalizer line is just downstream of the bulb. And then when I get into talking about a balance port valve, there's a push rod packing in here that can be damaged if it's overheated, and it could affect, if this equalizer line was before the bulb, you could actually get frosting of that. You could get some refrigerant coming down that equalizer line, and it would be frosted, and it would cause the bulb temperature to decrease on a false low superheat reading, and the valve will not feed. So we recommend that equalizer line just downstream of the bulb. Now, installation tips. We want to make sure that the bulb is the sensing bulb, again, because it's the major opening force and really the feedback to the expansion valve to open and close that valve. We say we want it mounted at either the 4 or the 8 o'clock position. If the connection sizes are 5/8 and below, then 12 o'clock is okay. We say either 4 or 8 o'clock because if there's any type of a liquid slug, that cold liquid is going to hit that bulb, and that bulb temperature is going to sense that cold liquid, and it's going to help close the valve quicker to protect that compressor. And then we never want to see it mounted at the 6 o'clock position because there's always oil trickling through the system, and we don't want that bulb to react to the oil temperature. We want it to react to the refrigerant vapor temperature. So we want to make sure it's on a horizontal section of the suction line at the outlet of the evaporator. Should not be exposed to the air streams within the fixture. And then tighten all the TEV sensing bulbs with the appropriate bulb straps. And then on the equalizer location, always that equalizer line, make sure it's on the top of the suction line, and then make sure that it's located downstream of the bulb. Then if you look at when you're mounting the bulb, make sure it's on a clean piece of pipe so that bulb is sensing that pipe temperature or that vapor temperature. Want to make sure it's not on a coupling where you could get an air gap in between the bulb and the suction line. And then with the straps, the bulb straps that we include with our expansion valves, Now, this is a proper way to install the bulb on the suction line, as opposed to having the bolts on the back side of the bulb. Here you can see this even the clamp temperature is going to help that bulb sense that refrigerant vapor temperature, where if you attach it like this, you're going to see that little bit of an air gap here that may affect it. As far as installation tip, now this does not apply to the expansion valves that are on the Mestec or the SpacePak evaporators. They use a mechanical connection. However, this is important when installing brazing in expansion valves. You want to make sure you don't need to disassemble the valve. Direct the flame away from the valve body. Avoid using an oversized tip. Avoid excessive heat on the diaphragm, and keep the flame away from the bulb. And then, as far as keeping the system clean, as I mentioned in the first slide, the port size on the expansion valve is very small. And if you don't use nitrogen during that brazing process, you can get that black flaky oxidation that can end up in the port of that expansion valve. And when that expansion valve should be closed, you're going to get some seat leakage, and it's going to simulate a low superheat. Now, in the beginning, I've said, dealing with expansion valve issues over the last 16 years, I've seen the good, the bad, and the ugly. One of the ugly was a contractor was brazing in an expansion valve, wasn't paying attention, and he ended up putting excessive heat on the diaphragm of the valve, and the diaphragm actually ended up separating from the lock nut, because there is a gas pressure that is enclosed in that bulb, and it got to the point where he hit it with a torch, and it ended up separating from the lock nut to the diaphragm. So just pay attention when you're brazing in expansion valves, because there is pressure between the bulb and that diaphragm. You want to make sure that when that oil leaves the compressor, you want to make sure that oil circulates through the system, so it helps lubricate the expansion valve and the system components. And you want to make sure that suction line is sized properly, so you get that oil back to the compressor where it belongs. So suction lines, you want to make sure that they're small enough to ensure sufficient velocity to carry that oil back to the compressor, but you want to make sure that they're large enough so you don't have a very large pressure drop in that suction line, and that can affect your compression ratio on your compressor. So now we talked about conventional port expansion valves earlier. Now all the 410A valves and the CBBI Z valve that SpacePak uses is a balanced port valve. And all that a balanced port valve does is really, let me just back up for a minute. The conventional port, there's really one other pressure that helps open up the expansion valve. And that's when that liquid pressure comes in, it acts down on that pin, and it helps open up the expansion valve. So because of the changing inlet pressures of the 410A, 410A needs to be a balanced port expansion valve. And all that a balanced port expansion valve does is when that inlet pressure comes in, it acts down. Here's an exploded view of the internal parts of the balanced port valve. And so when that inlet pressure comes in, that inlet pressure acts down on this cone area, which helps open the valve. But if you look right here, there's like a sleeve that's on that push rod. The cone area equals the sleeve area on the top. So as that inlet pressure comes in, it helps open the valve, and it helps closes the valve at the same pressure. So it offsets the inlet pressure. So once your superheat is adjusted for, say, 10 or 12 degrees superheat, if there's a change in inlet pressure, it's not going to be affected with a balanced port expansion valve. So when this diaphragm deflects down, it moves this pin away from the port of the valve, and now that refrigerant goes to the outlet connection and enters into the evaporator. So if you look, I mentioned if the external equalizer line is frosted up and it's a brazed expansion valve, you can see right up here with this push rod, right? So the inlet pressure comes in, and as that diaphragm deflects down, this pin moves away from the port, and now the refrigerant goes into the evaporator. But you can see there's a push rod seal right up here, and if you overheat the valve, you can compromise this push rod seal. Now you can get refrigerant pressure coming up here, coming to the top of the diaphragm, and then it can work its way down the equalizer line. However, you should not have that situation with the expansion valves on the SpacePak, because they do use a mechanical connection instead of a braze connection. Then also, as far as TEV expansion valves with 410A in their nominal capacities, I just wanted to point out what an effect liquid temperature and pressure drop has on an expansion valve. So if you look at a nominal capacity expansion valve with 410A, it's nominal. It means that at a 40-degree evaporator temperature, 100-degree liquid feeding the inlet of the expansion valve, and 160-pound pressure drop across the expansion valve. That's what that valve is not nominally rated for. So the colder the liquid feeding the expansion valve, so if you have 80-degree liquid feeding that expansion valve instead of 100-degree liquid, you're going to add 12% capacity. As you get more pressure drop across that valve, and where that pressure drop comes from across the valve is basically your head pressure minus your evaporator pressure minus your distributor pressure drop. So most situations, 160 is nominal, so that's why we use a 1.0. But as you have more pressure drop across the expansion valve, you can move more refrigerant through the port of the valve, so it increases the capacity. So if you have a 200-pound pressure drop across the valve, you're going to increase that capacity 12%. So just be aware it's a nominal rating, and liquid temperature feeding the valve and pressure drop across the valve affects the expansion valve capacity. So as far as adjusting the expansion valve, remove the bottom cap assembly. The valves that SpacePak uses, there's no packing nut to loosen. So you just take off the seal cap. Always be patient when adjusting expansion valves. Give them a quarter to a half turn. Clockwise increases the superheat setting. Let it settle out for 15 or 20 minutes before you take the next superheat reading, and then just keep adjusting as needed. And then once your superheat is adjusted, just make sure you tighten the packing nut, put the seal cap back onto the expansion valve. So that's how you would adjust the superheat on an adjustable style expansion valve. Now we also make non-adjustable expansion valves as well. So if you ever have a non-adjustable expansion valve, you can always convert it into an adjustable expansion valve by ordering a adjustable bottom cap assembly, which I'm showing right here. And then I also get asked, what do we set our expansion valves from the factory? And really, we don't know what they're being hooked up to, what they're being installed, how the evaporator, condensing unit, and the compressors are being matched. So if you take a look at that CPBI valve that SpacePak is using, there's a total of 8 turns of adjustment on that expansion valve. And then when we send that out to SpacePak, it should be in the midway point. So you would have 4 turns in or 4 turns out when adjusting your expansion valve. And just to back up for a minute here, one thing I didn't mention, when adjusting your superheat, especially on a startup, if you need to adjust it in or adjust it out, always keep track of the number of turns so that you know how far you are from the factory setting. And then On the expansion valves on the SpacePak unit, they using the GA charge, and this is showing the thermostatic charge on the expansion valve. So on the left is the superheat. So here we have 5 degree, 10 degree superheat, and then we have the dotted line, and then on the x-axis we have evaporator temperature. So if you look at 40 degree evaporator temperature, and if you go up and you see where that VGA charge is, that's really right at that midway point of that superheat range. So with the GA charge, it's really the ideal charge for air conditioning and heat pump applications. The constituents in thermal balance used with the GA charge provides exceptional anti-hunting characteristics for these valves. So here we're showing our air conditioning charges. Then we have 410A. So the charge on the CBBI valves is a ZGA charge. So the Z would represent 410A, and the GA is the air conditioning charge. So now, troubleshooting expansion valves. So troubleshooting expansion valves. When I get a call from a contractor and they say they're having an issue with an expansion valve, what do you think my first question is? My first question is, well, what's the superheat? And sometimes sometimes the answer is, well, it's beer can cold. Which really we need to know, what the superheat is. So you need to take out your gauges, take out your temperature meter. If you're not feeling well, you go to the doctor. What's the first thing the doctor does? He takes your blood pressure, he takes your temperature, to help find out, what's going on. It's really no different than an expansion valve. Take out your gauges, take out your temperature meter, find out, what's your suction pressure doing. Is your superheat high? Is your superheat low? And what are the situations? So basically, it boils down into 3 different scenarios. The first one is the TEV is starving, so there's high superheat and low suction pressure. So immediately, I think maybe there's a restriction in that liquid line somewhere that's causing that. Second scenario is the TEV overfeeds, so it has low superheat and it has high suction pressure. And then the number 3 is the TEV hunts. It has high superheat then low superheat, and it's hunting. So let's take a look at what are some of the causes. So high superheat, low suction pressure. What are some of the causes? Contamination. Moisture, dirt, or wax in the system. It's going to get caught in the port of the expansion valve, or it could plug up the inlet strainer on the expansion valves. Could be high superheat adjustment. Could be a dead thermostatic charge. There is, as I mentioned earlier, there is a cross gas charge in the bulb, and if there's a leak in the bulb, you could have a dead element. You could have a wrong thermostatic charge. No external equalizer or an external equalizer location. If it's before the bulb and the equalizer line is frost up, this would be the scenario. If you have a capped equalizer line, which I mentioned earlier, that simulates a dead element or low suction pressure, high superheat. Low refrigerant charge. If there's low charge, it'll simulate high suction pressure, low superheat. Flashing at the TEV inlet. We always want to make sure that we have subcooled liquid feeding the inlet of the expansion valve. There's a filter dryer on the liquid line, and that filter dryer is plugged up. We're not getting a full column of liquid. You're going to get low suction pressure, high superheat, or if there's an undersized expansion valve. So now let's take a look at identifying a dead element on an expansion valve. Check the cap tube for any type of damage, if it's kinked, if it's rubbed through, or if it's cracked. You can always take the bulb out and put it in warm or cold water to see if the expansion valve opens up and feeds more refrigerant into the evaporator. If you do have a bad element on the CBBI valves that are installed on the SpacePak units, you can replace just the element. However, you want to make sure that the refrigerant is removed from that system, because once you take off that element, you will get refrigerant coming up through the equalizer line and coming up through the push rods. So and then get the proper element, and then the torque setting on the element is basically, it's a knife edge joint, so you make it hand tight, and then you take a wrench and you bring it over 60 degrees, or you tighten it one flat. So there's no gasket, it's a knife edge joint. And then if you take the old element off and and the buffer plate or the diaphragm deflects, it's time to replace that element. So a nice thing about it is you can replace just the element, you don't have to replace the whole valve. So now a situation we have low superheat, high suction pressure, and the valve is overfeeding. Again, I mentioned earlier, if you're brazing, don't use nitrogen. If there's any black flaky oxides in the port of that valve and the pin can't close down tight, you could get TEV seat leakage. Low superheat adjustment. I've seen some installations where the bulb isn't strapped down with clamps, and over a period of time the bulb separates from the suction line. If you have moisture, dirt, or wax in the system, or if you have an oversized expansion valve. So again, low superheat, high suction pressure. Here are some of the causes. And then if the TEV is hunting, you could have, what are some of the causes? Could be low load, oversized expansion valve, oil logging in the system. If something is, maybe piped a little bit funky, or you're not getting oil back to the compressor, you get TEV hunting. Poor airflow or poor refrigerant distribution, which we'll talk about in a minute. Just like when I was talking about cleaning condensers, right? It's important to make sure you replace your air filters so you get that heat load over the evaporator, so you can boil off that saturated refrigerant in the evaporators, and obviously that would contribute to low load or poor airflow. And then also taking a look at the evaporator and the distributor, they require, proper nozzle selection, proper circuit diameter, adequate surface area, sufficient airflow. So again, you want to make sure you have enough airflow to absorb that, get that heat over the evaporator, so that you can boil off that cold saturated refrigerant in the evaporator. So TEV is hunting, or an odd frost pattern, could be caused by uneven air distribution or flow, poor refrigerant distribution. You can check the circuit loading, check the nozzle sizing. Is the coil severely frosted, or are any of the circuit tubes restricted? So here's a nice way to be able to check if you're getting proper distribution out of the expansion valve and into the distributor tube. So check the tube balance. Check each circuit tube on the circuit before it hits the suction manifold, and each circuit should be within 3 or 4 degrees from each other. If this bottom one is frosted up and it's cold, and the top one doesn't have any frost on it and it's a lot warmer, then maybe the nozzle, or there's an oversized nozzle in that distributor. But that's a quick check to see, to check on your distributor to see if it's distributed properly into the evaporator. And then making sure you install a catch-all filter dryer in the liquid line. These are actual expansion valve components that we receive back in our warranty department, because our expansion valves weren't working properly. So here you see a pin on an expansion valve. Here it looks like overheated oil. So that would definitely be high discharge temperatures. Here you can see rust, so that'd be moisture. Here you can see an inlet strainer. Maybe not using nitrogen during that brazing process. So by using a catch-all filter dryer, it helps keep that refrigerant clean so that you're not going to contaminate the components in that system. So if you look at how the liquid line, how the refrigerant flows through the catch-all filter dryer, basically it comes to the inlet. Any contamination or debris gets filtered around the whole perimeter of the core. And then in the core, there's two ingredients. One is activated alumina, which absorbs acid, and the other is molecular sieve, which absorbs moisture. So every time that liquid passes through that core, it absorbs more moisture and neutralizes the acid. And then here's a 20 micron pad on the outlet side to help keep that refrigerant clean, keep the refrigerant neutral, and help keep that refrigerant free of any type of moisture. So what are the when do you require a catch-all filter dryer? Initial required on an install, and I think it's always a good idea to put the filter dryer at right before the inlet of the expansion valve, because now if you're not as careful as you should be during the nitrogen purge during the brazing process, you have a lot more surface area of the catch-all filter dryer to catch that contamination rather than it being caught in the port of the expansion valve. So I think the best spot to put the catch-all filter dryer is right before the expansion valve. Whenever the system is open for service or repair, you want to install a new catch-all filter dryer. We talked about you want to make sure that you get a full column of liquid to the inlet of the expansion valve. So the liquid line filter pressure drop exceeds 5 psi. It's time to remove that filter dryer and install a new one. If you have a moisture indicator in the system, if the sight glass is yellow, meaning there's moisture in the system, then change that filter dryer to help clean that, help dry that refrigerant. If you had a compressor burnout or if acid is present, you want to change those dryers to neutralize that acid in that refrigerant. And obviously during a compressor burnout cleanup process, we recommend installing an oversized liquid line filter dryer to help increase the capacity of absorbing the acid from that liquid refrigerant. And then during a major compressor burnout cleanup, install a suction line filter dryer to remove acids and debris from the suction line quickly. And then after a successful burnout cleanup process, renew protective capacity. So catch-all filter dryer plays a key role into the health of the system. And then if you ever have an issue with an expansion valve, you can always identify what expansion valve is on that system. We stamp the nomenclature on the expansion valve. So the expansion valves on the Mestech equipment, you would see a CBBIZE. So the CBBI is the model of the valve, and then whatever the capacity is. And then up top, you'll see the charge that is on that expansion valve as well.
Hey, Dana, we got a quick question here.
Yeah.
A question here came from Eric of Mestech, actually, are these valves, the ones for the Mestech ones, are they bleed or non-bleed? What is a bleed type and why would it be important?
Oh, that's an awesome question. Great question. Yeah, so the ones that you purchase are non-bleed, okay? And I'm just going to back up here because I'm going to show kind of what a bleed port valve, how it's built. Okay, so yeah, so the ones that you have are non-bleed, okay? All that we do for a bleed port, like standard would be like a 15% bleed. And if you look at my laser here, we basically just drill in here so that we constantly bleed 15% in parallel to the port of the expansion valve. And from what I've seen, the need for a bleed port expansion valve has increased over the years with 410A and with micro channel condensers. And what happens is if you don't have a bleed port with micro channel condensers in 410A, it almost becomes a critically charged system. And the issue that the micro channel condenser the issue that I've run into is there's very little internal volume with the microchannel condenser. So the compressor starts up, and if you don't have that 15% bleed through the port of the expansion valve, this expansion valve doesn't open up quick enough, so the compressor cuts out on a high nuisance pressure trip. Okay, so if you have a microchannel condenser, it almost becomes like a critically charged system. And if you have a little bit extra refrigerant in there, it's going to trip out on a high pressure nuisance trip. Okay. The advantage of a tube and fin, there's more internal volume, so it's almost like a hydronic system with an expansion tank. So when that compressor starts up, there's almost with a tube and fin, there's almost somewhere for that 410A to burp to give it enough time for this expansion valve to open up, so you're not going to trip that compressor. Good question. Hopefully I answered it. Answered it so you can understand it okay. Any other questions? So getting back to the slide that I was on here. So if you ever need help on the Sporlan side, I know we're talking about Sporlan expansion valves, but I know you guys work on other systems as well. So if you ever need any help on any Sporlan components, please reach out, give us a call. We'll be more than happy to help you out. And then here's our website. There's all this information and more is on sporlan.com. We have a lot of good product information on here, educational information as well. And then there's our tech support number, which is located in Washington, Missouri. And then there's their email information as well.
Dana, one more quick question, it looks like, from Chuck Greenberg.
Sure.
When shutting down a system, how long should it take for the TXV valve to equalize?
That's a good question. I'm not sure. Yeah, good. Yeah, yeah. I'm not. Yeah, I'm not sure on that. We'll have to research that and get back. I think it may depend on. Well, yeah, I'm gonna have to. Yeah, I'm not sure on that. We're gonna have to get back to you on that question. Good question. I'm not sure if I can answer that accurately.
Okay, so just so everyone knows, as we're kind of wrapping up here, if there's any outstanding questions like Chuck's question there that Dana just presented, we'll send that out along with the follow-up, the recording and things like that for from this meeting. So as you're kind of looking at the last slide here, Dana obviously had his, for Sporlan, all the contact information, tech support. Also, don't forget, right, we have all the support here at SpacePak as well, the pre-sale team, our technical support team as well, which I did see a lot of them on this meeting, which I wanted to thank them for taking time out to be here to help learn this. So if there's no other questions, again, I'd like to thank everybody for joining. I'd like to thank Dana, of course, specifically for doing the presentation, and hopefully this helps you guys in the future, and again, help reduce some of the callbacks and some of the issues you guys may be seeing out there. All right, very good. Well, thanks everyone, and enjoy the rest of your Monday.
Thank you.
Thank you, Dana.
Thanks all.